Swayam Prabha. Digital India. Educated India.
My name is Dishant. I work in Institute for Mathematical Science, and I'm going to. So probably there was no title given for this talk. Was there any title given to you? Okay. So let's not keep any title on this. What I'm going to start with is what I would call a very unsettling story. Unsettling story about electrons. So everybody is familiar with electrons? Yeah? So in this talk I am going to denote electron by this symbol. Okay? So I want to tell you the behavior of this electron and then the reason for me telling this behavior, which is according to me very unsettling and difficult to comprehend, is that though we understand some things about behaviors now with more sophisticated mathematics, I strongly believe that there is a lot of scope for improvement in our understanding, and I hope one of you will take up this when you take up your career and maybe give deeper insight into what is going on. Yeah. So first thing, can all of you hear me clearly? Yeah. So any particle like electron, we know about them by some measurable physical properties, correct? Because of course this is not a particle that we can see. It's not even clear whether it's a particle, but whatever, it's some that such an object or whatever you call exists is through its physical properties. Okay, so instead of telling technical name of the physical property, I just want to tell you a few facts, which are the experimental facts, which you take as your assumption for this lecture. I will tell you how those facts have been derived, but I can't describe the experimental setup. Okay, so electron has to be. So there are three kinds of physical property of electron that I want to discuss, and I am going to call those three property as, first is, so and these properties are physical properties, like something is black in color and things like that. Okay, so I am going to call the first property as color of an electron. Okay, this is not the real name of this property, but I am going to call it color for making discussion simple. Okay, but what is important for us is that this is a detectable property, and till now whatever experiments we have done, the electron can come only in two colors. There is a white electron and there is a black electron. Okay, so it's a binary property. If you take an electron, if you conduct an experiment of measuring its color, there are two outcomes. For one outcome I call white, another outcome I call black. It has never been the case that somebody has observed any third outcome. So there is no green color, there is no red color. Now how this color of an electron is measured, we will just go in a schematic, we will just describe this schematically. So there is something called as color box. So there is something called as color box. What does it have? It has an input, and I can input single electron at a time, okay, and it has two output. So if the electron comes out of this, I will call it as a black electron. If it comes out of this, I will call it as white electron, okay. And now how do you verify that they are actually distinct properties of electron? Because, so let us call this box as WB box, okay, means it is distinguishing white and black electrons. So how do you know it is doing it? If I insert an electron and it comes out of this, okay, and I suppose put a mirror here, or even better, I just take this white electron. I am not able to draw, but let us say there is another input of the same kind of box given here, and the electron enters that box, it again comes out from the same side, okay. So imagine that an electron has entered here and it has come out from the top, then the top electron that has come out, I straight away insert into the same kind of box, and again it will come out from the top. That means it is a persistent property. So its color is now determined, because it is any number of repetition of this experiment, as long as you don't tamper with the electron, keeps on giving you white color, okay. It's like some property of a substance that is say hard. So if you keep measuring it without tempering, then it will remain hard. What I mean by tempering is that, for example, there could be a substance which you put in water, it becomes slightly soft, and then if you take it out of water and then you press it, it has become soft. So, but as long as you don't make it interact with the physical world around it, its property remains, okay. That's how we deduce that it's a white electron, okay. So, is it clear what I am saying? So, there is a color box which I call WB box that determines the color of an electron, okay. Is it clear to you? And by determining color means it's a repeatable process. Once I know that an electron is white, I again make it pass through the color box and it gives me as an output a white electron. And how do you know that it is a white electron? You only know it from where it exists, this box, okay. Now these boxes can be made in many ways, but that is irrelevant. What is relevant for this lecture, being a theory lecture, is that there is such a box, okay. Similarly, so that is similarly, so this is color of, but there is another property of an electron which I would call as handedness. Okay, meaning just like most human, an electron is left-handed or an electron is right-handed, okay. Okay, so this is another property. How do you measure this property? Similar way, you instead of making a color box, which I call WB box, you make a handed box. So you make an electron enter here, any electron, it will exit from one of these two, and that will determine whether it is left-handed or right-handed, okay. So it's a binary property. There is no electron that can do things like humans, some things with left hand and something with right hand. If an electron has decided to be left-handed, it is left-handed, okay. It's 1 or 0, left-handed or right-handed, okay. And the way in which we confirm that it's a left-handed electron is by just putting a similar setup. Yeah, is it clear? So instead of this color box, I have another box, so which I am not drawing, but let's call LR box. Okay. Now, what is the statistics? If I in a lab I produce a beam of electrons, okay, a very low intensity. So one electron is going inside my apparatus at a time, and I continue this experiment in a random collection of electron, meaning just that you produce in a laboratory. About 50% exactly, in fact 50% are white and 50% are black. Yeah, so it's half and half. Given an electron, it will be either black and white, but given a collection of say 100 electron, 50 are white, 50 are black. Statistical. Yeah, is it clear? And that is actually no surprise, because if you have a binary property and if you take a bunch of electron without any, like not a kind where I have actually make them pass through a color box and measure that they are all white and then put it again, which they be 100% white. If you don't do any such thing, it is sort of natural to expect that some of them will be black, some of them will be white, and 50-50 is not a very surprising fact. Do you agree? The same thing is true for this. There are 50% right-handed electrons and 50% left-handed electrons. Okay. Now, let us try to understand whether there is any correlation between these two properties. So, I want to first show that there is no correlation between these two properties. How will you show? What I mean by correlation? Is it true that if I take a white electron randomly, it is likely to be left-handed than right-handed? Okay. So, if I take this a white electron, meaning I select a white electron by passing it through a white electron selecting device, and then I make it enter the handedness device. If white electron is biased towards left-handed being left-handed, then the statistics won't be 50-50. 70% of white electron will be say left-handed and 30% of white electron will be right-handed, something like this. Okay. So, to check that handedness and color are independent properties, we have to take a beam of white electron and make it pass through this handedness device, which determines its handedness. And so, if we do that experimentally, 50% of white electrons are left-handed and 50% of white electron are right-handed. Is it clear? So, a white electron has same okay. So, white electron statistics is no different from a bunch of electrons that I have produced in a lab without knowing whether they are white or black. I select white electron and I make it pass through the hardness box. 50% of them turned out to be left-handed and 50% turned out to be right-handed. So, if this is true, then I hope all of you agree that there doesn't seem to be any correlation between the color of an electron, at least white color of an electron, and its handedness. Okay. Similarly, I can take a black electron and carry out the experiment. I have the same statistics. Okay. I can turn around and I can take right-handed electron and try to understand its color. Okay. Then maybe there is only one way statistic, that okay, white electron are 50-50, but the other way it is not true. So, we take some left-handed electrons, a bunch of left-handed electron, which now we can take because we have a box that makes left-handed electrons. So, we block a channel that makes the right-handed electron exit and only keep the channel where only left-handed electron comes out. So, we have now a beam of left-handed electron, and then I can put that beam into a color box which determines black and white, and I can check what is the statistics, whether there is a bias towards color for a left-handed electron, just to be safe. And no such bias has been ever found. To the best of our knowledge, our experimental limits, which are quite accurate now as of 2020, there is no correlation between these two properties in this sense. Okay? All these properties are repeatable, they are binary, and they don't have any correlation. So if you have been given a left-handed electron with no information of its color, there is no way to infer that it is this color or likely to be this color or that color. Okay? Is it clear to everybody? Just it's some physical property that you can measure. If you take a beam of electron, think of like this experiment, take a beam of electron and you put in a device, okay, and from that device two beams come, one go on the left side and one go on the right side, okay. Now you collect the beam which is on the left side and again put in the same device, the beam on the right side just completely stops, electron only keeps going on the left side again. That means that electron prefers to be on the left side. So that's a physical property. Being a electron, there is no other way to tell what it is, correct? So it's a beam splitter. But this, you should not think that there is a beam in the sense that many electrons are coming. One electron is sent at a time and it is collected on the left side or right side. So that is a property that is, say, left-handed. Because if it went to left side, you call it left-handed. I don't want to give you the technical name of that property because it's irrelevant. What happens in practice is you see that there is a distinct property of electron that makes it favor one over the other, and that's a physical property. Now if I take that electron and I pass through any number of handedness box, it's always going to exit from the left side. So it's predetermined, means you have tuned your electron to behave in some way, means you have fixed its physical property. Is it clear? That's all it means. Anything else? Any other question? Yeah? And yeah. So similarly, color is something like that. There is a beam of electron and it will split in some way. And what I am saying is that, well, of course, you have to check that both your boxes are measuring some other property, and that is checked by, if I take a color box and then it went into, say, up, and then I put it into the handed box, it can go left or right. It doesn't fix one particular side. So then this is a distinct property, because if I again put in the color box and it has to exit up, it will always keep exiting from the upside wherever you enter. Yeah? Okay, so they are distinct properties so far as we know. Okay, so is it clear that none of this, so if I take any of this particular kind of electron and try to measure its another property, the statistic is 50-50. Half of them are divided. So each white electron, 50% of them is left-handed, 50% of them right-handed. Black electron also is true, or other way around, left-handed electron, 50% are white, 50% of black, and so on and so forth. So all four possibilities you can check for yourself. Yeah. Now, let's do the following experiment. You take, so I'm going to just write as a box, which I'll call it a WB box, okay, white and black. And let's say I send an electron inside, and so it came out and I put it into handed box. So this is left-right box, okay. Say it came out as a white electron and then I put it inside the left-handed, right-handed box, okay. Now So so remember that electron went inside here and came out as a white electron and then entered the left and right distinguishing box, handedness box, and then came as say right handed. And then I again insert this electron into the same WB box. What do you expect? Where should it come out from? It should come out, if a logic that we are familiar with, it should come out as a white electron. Because I have a white electron which has been, I don't care left-handed or right-handed, it measured it, but we know the statistic of that is no correlation, so white electron comes out as a white electron. Yeah? Everybody agrees? So expectation is should come out. Yeah, a white electron should come out because I had a beam of electron from which I selected white electron, which I explained what it means to select a white electron, then put it into handedness box. I randomly picked either right-handed or left-handed. It doesn't matter what I pick, and then I put it again into the color box. And we know that color box, if once it measures that it is a white electron, it continues to show you white electron, because if I take a white electron and put it in a color box, again it's always giving a white electron, correct? Well, surprise, surprise, if you do this experiment, 50% are black and 50% are white. Okay. So now you may say that, well, somehow measuring process of its handedness disturbs the electron and sort of makes it change. So yeah, that's a valid question to ask. So how do you go about verifying this? First you try to find out, how do I know which electron change color? Because there is some electron which change color. But if all the electron white that entered and exited as white electron and didn't change the color, then this 100% of electron that comes out should be white. That's the most natural thing to expect in our day. Yeah. If a person, just imagine that you have two property, you are a tall person and you are left-handed, and then it will never happen that you are tall and then you write with your left hand and you become short. I mean, this is unheard of, it, correct? So as far as we can see, this is a very strange behavior. Yeah. So one would like to know that maybe which electron which looks which is white changes its color to black, because some of them don't change, some of them change. Yeah. Okay, so the experiment on these lines have been conducted. So how do you kind of try to understand which electron changes the color? What you do is you prepare an electron beam having as many properties as we know till date, physical property, because you have to list all the physical property and then create two identical electron. But you can't just create two, you have to create a bunch of identical electron, which doesn't involve, which not only involves this kind of property, all other properties that we know. For example, charge, of course charge won't change, but all the physical properties that we know, spin. So if I take this identical electron, otherwise identical, and then conduct this experiment, so far as we know, it's always been that 50% change their color and 50% don't. Okay? Yeah?
Sir, earlier we had said that if you put the electron to the white
Yeah, it contradicts. So let's just write, yeah, that's what is I'm telling is that if you remember, I started the lecture by saying that I am going to tell you a very unsettling story. Unsettling for logic, that electron has a way of doing things which is not very obvious from our current logic that we use. Yeah.
So, does this swap only happen when there's a left right reading in between, or does this swap happen even if it's just a row of white black?
Row of?
White black.
No, if you put white black boxes one after another, it will, if it comes out as white, it will be white all the time. So unless of course you do a major tempering. For example, say you are a left-handed, but if your right hand is broken, then you will, so, and I am an observer I am an alien who is observing, and I mark you as a left-handed, and suddenly one day I see you writing as a right-handed, I am confused. But then the reason is that, okay, you had a fracture in your left hand, so it's a tempering. It's a tempering with your physical property. So if you don't do any such thing, it is always white remain. 1 second, white remains white.
So the swap only happens when we do a reading for left or right.
Okay, so it certainly happens when you do reading or left or right, and doesn't happen if you don't tamper with it. It can happen that you can do some other measurement and it still remains white. Yeah. He wants to answer. 1 second.
So, in this setup, instead of just wire, we had the left-right box and white-black box in the middle, and then a left-right box. Say the original electron that enters the first LR box is
Let me write your set. Let me draw your setup. Okay. So LR.
LR, WB, and then
Yeah.
the initial electron measurement is left. Okay.
Left. Okay. So I am not going to I am just saying that beam comes out here is left. Okay. I mean there is a setup, but we don't care. We will collect and it is entering here. Yes.
So will it turn out that after it passes through the WB box and we get the final reading in the last LR box, it will be 50-50 LR or 50.
I didn't understand. So it came out as a left. Then 50 of them are white and 50 of them are black. Now what do you do?
Now it's again entering the final LR.
But the both beams or one beam?
One beam.
Okay. So which one? White. You have to make one electron enter the box at a time.
Then say we choose the white electron.
Okay. Choose white electron. Yeah.
Now these white electrons are entering there.
So now they are actually left-handed white electron. Yeah.
So will the handedness change after entering the final LR box?
Yes, it will change exactly as what happened to the color. 50% will change their handedness to right, 50% will change their handedness to left. Yes. If you change the order of the apparatus and repeat the experiment, it will change. You can, instead of making in your experiment, make it enter black, same thing will happen. Okay. And additionally I am saying is that how strange this is that if I fix all the measurable property of an electron, okay, and I now, so now because some of them are changing color clearly, or some of them are changing handedness, whichever way you took. First you measure handedness, then it is changing handedness. First you measure color, then it is changing color. Okay. So of course it's a natural question was which electron, what is it that making electron change? Because it is conceivable that there is some third or fourth physical property which has a consequence that it will, whenever electron passes through this, its handedness is determined. It means that this property of the electron is correlated with some other property that is making it change its color or change its handedness. Is it clear? Yeah. No. What I say is no correlation, meaning if I am given a white electron and if I send it to handedness box, 50% of them are left-handed, 50% of them are right-handed. So certainly there is no correlation, because if there was a correlation, it won't be this statistic, correct? It is randomly either they are left-handed or right-handed in a measurement. If there was a correlation of any kind, that at least we can measure, okay, that experiments can measure. How will you find a correlation? You will have to do some experiment, correct? So what experiment you do? You just take a white electron and make it to its left-handedness or right-handedness, the device that decides, and each identical white electron physically, with what you mean by identical means all the measurable property of electrons are identical. Of course, you can always say that we as humans don't know all the measurable physical property, and which is quite conceivable. There may be some property that we don't know, but all the properties that we know, you keep identical and keep its color white, and then you send it to this handedness box. 50% of them are left-handed, 50% of them are right-handed, and so therefore you say that there is no correlation, yeah, so far as we know. But of course it is conceivable that there is some strange property, that is all the properties that we know of electron till date are related by some property that we have not yet discovered, okay, and that's why I am even lecturing, otherwise there is no point of lecturing. I want you guys to maybe prove something like that, though I am saying it's very unlikely that that's the case, because the experiments are really fine. Reason may be something else, but even if there is such a reason, we don't know it, okay. So far as we know, they are completely unrelated. Anything else? Okay. Now, is everyone clear? Everyone is clear? Okay. So now let's just make the experiment slightly more complicated, okay? Okay, so let's take, say, take a LR box, okay, and you know that anything that is coming out here is, did I write left or right? Okay, doesn't matter, give me some symbol. Going up is left, going like this is right, okay. Now what I do is I put some reflective surface like a mirror, okay, and I put a, what I call is a black box here. Okay, so let me first explain what is this setup. So this is just usual left-handed and right-handed box. An electron enters here, and what is this is just some harmless mirror which just makes it reflect and go into one particular place. And the purpose of this black box is that then it channelizes into one direction, okay. Now of course you can say that this is, we have to make sure that this arrangement is not tampering with the electron. So for example, if I make after this arrangement, so if I make a left-handed electron enter here, okay, and then I measure again its handedness here, it is left-handed, okay. Is it clear? So it means it's okay. Now So now let's say I take, so what happens is if I put an arbitrary beam of an electron here, after all this setup I keep, as soon as electron exists I mark whether it is left or right, left or right. What do I expect? 50% of them should be left-handed, 50% of them should be right-handed. That's what happens. Okay. So that means this, after additional of these things, we have not changed this box's property. So if I think of this inside a bigger box, it's still a left-right box. Is it clear? Because if I measure here, the statistic is same. Again, if I make a left-handed electron here, enter here, and I measure it here, it remains left-handed. Is it clear? That's how I show that these mirrors that I have put, reflecting surface, is not somehow altering the electron. Yeah. Now, let's say now I put a beam of white electrons here. Okay, and I start measuring what kind of color here it is. So I don't measure. So if I measure, of course, so let's say, let me write it here. This comes here, and then I send it to WB box. So white electron enters this setup and exits, and I now measure its color. What is the expected statistics of this? From the previous thing, what is the expectation? 50% will change their color. Correct? Because this setup is same as WB box followed by error box followed by WB box. Color box followed by handedness box followed by color box. You agree? Except for those mirrors, and which I checked that the mirrors are not tampering with his handedness or anything. Okay? And now, of course, electrons are very strange. The statistic is 100% comes out white. This is even more disturbing, correct? Because nothing that we think, okay, maybe measuring color in handedness in some way disturbs color. But here is an experiment where 100% of them come out white. Yeah? You can change the, I am telling you that I explained that you check the reflection and measure here, whatever handedness is there, the same handedness remains. But it can change color, because we have already seen that if you color box followed by handedness box, color may change. What is surprising is that it doesn't change just by putting mirror. It's kind of strange.
So in this case, since the input beam coming into the initial work is the same as the beam that's going on.
Same. How do you measure? I'll tell you. What you do is, so this is how it's the same beam. It's the same beam. It's just a path. It's just a channel. Like you have seen this fiber optics, which channels the light, is like that. You just channel it so that it collects at one particular point.
Then the initial beam itself was 100%.
Initial beam I put it as 100% white, but remember, if I had put in this setup 100% white, half of them change the color, because if I had white black box, I collected the beam of white electron and inserted. Here white electron is obtained by making it pass through some, because if I produce in a lab a beam of electron, I won't know what is white and left. So I have to make it pass through some device, and this device is generally some kind of magnets that affects that property. Okay, and it kind of splits the beam.
So just by adding the mirror and making the same beam come out, we are stopping the 50-50 change.
Yeah.
in the previous setup, the white electrons after being passed through the antenna's box, 50% is left and 50% is right. But to pass through the second white and black box, we are taking only the right.
You can take also all the left one. You can put another box on the top that measures the color of the left-handed box, and they will all have changed the color.
So, but over here we are converting the left-handed electrons and the right-handed electrons into one box and pass.
No, but at a time there is not a beam. At a time only one electron goes. I am just describing the path, nothing else.
They do not converge in that box.
No, there are not like many electrons going and going. One electron at a time. Pung, pung. You will see like it's coming one at a time. In fact, I'll tell you, people have done an experiment where they have say, okay, that's a good question. Maybe electrons are interacting. So what they do is, they make one electron pass, then they stop the experiment for 24 hours, then the next electron pass, then the next electron pass. It's like as slowly you want to make one electron pass as you want. And yeah. Okay, let's continue.
If I could change this setup in a way that I take two white boxes and pass the
White boxes, color boxes.
color boxes, and then pass the left-handed electrons into one of the color box and the right-handed electrons into another color box. Would I still get the same result, or would it be
Can you repeat?
the left-handed electrons that come out of the right box? I take it and put and pass through a color box, a separate color box, and take the right-handed electron and pass through a separate color box.
Statistic is the same.
Statistics is still the same.
Yeah. But what I am saying is that I am describing is a beam because generally electrons are described as a beam, but don't think of them as a beam. They are actually single electron coming. They are not coming like a light. But but there are surfaces that can reflect, and also therefore I am thinking that I am calling it a beam. But experiment whether you do it one electron at a time or you make in 1 millisecond one electron pass, so it is continuously some electron passes. Whichever way you do, any setup you do, what I said statistically remains constant. She wants to come. Yeah. Property of black box is just a collection of mirror that directs the beam. And I make sure that it's not altering property, because if I take some physical property and make it pass through and measure it after it exits the black box, I get the same property back. No, if we take black electron as an input, it pass through this setup, you get black electron output. It doesn't change its. So first setup, when I make it pass through the handedness box, randomly some electron changes color. Okay. But now in this experiment, it sort of refuses to change its color. And what we have done is nothing. We've just put some harmless mirror. Why harmless? Because physical property didn't change. You can, before you start your experiment of finding out its color, you can measure whether left-handed, if I measure here, somehow it has changed to right-handed or something. That all measurement is done before doing this. Okay, this is a schematic picture, but a very careful measurement of all physical properties are done to make sure that this doesn't alter the electron in any way. Any way again means from all the properties that we know as humans, we know so far of an electron. Is it clear? Yeah. Medium meaning electron, first of all, if you make it pass through some, say, water or something, is very likely to just ionize something. So to preserve electron, you should have essentially vacuum. I mean this region, because then there is otherwise always a probability that it will knock off, because it is a charged particle. It will do some interaction. It will ionize something in between, and so you can't then call that whether it was the same electron. Because if it hits an atom or something and then knocks off some other electron and continues, then it's not like that. It's the same electron. So therefore, these channels are generally not having any medium generally. Because if you put medium, then it has started interacting, correct? No. So here is the thing. This length of the path, if I am not correct, if I am not wrong, could be as long as 100 kilometers. And I think now there are experiments that they want to split a beam, send it and split it at the satellite level. So it appears to me that there is nothing to do with length of this. This length is quite long.
Sir, if the WB box before the 2 days and much, will you get it?
What do you mean by that? I have anyway taken one of the WB box here.
The output of the L and the output.
Here.
Yes, L is the-
But then you may want to tell me where the beam comes out and you again you collect it. What is your setup? You have to explain me the setup. Because it seems to me that when you put a box, it will split the beam. And that it does. Any beam you take, it will split.